remember that I have to close out the PowerPoint and then end the video. I'm talking to myself and my many personalities. Okay. So, all right, today I just collected your homework. I forgot 5th hour to show the key to last night's homework at the end of this. I did do that 1st hour. Sorry, 5th hour. Remind me 6th hour if I forget to do that. But I think it was because I was trying to produce a movie and then things went wrong. So now I'm taping 6th hour. There's my story. All right. Now remember, back up here, just looking at one sample. You don't know about one sample yet. We'll wait till we do the 2 samples and we'll say the difference there. But remember when sigma, which is the standard deviation of the population, was unknown when we did confidence intervals before break, we had to go to our t-chart. I should have told you to do that. Get your t-chart out if you have one. I didn't do it till this morning, and I promise you I'd do it yesterday, but I did put the Z and T charts on yesterday's and today's calendar thing. And actually within this PowerPoint, I can access it. And for the first time in forever, I'll pull it up and then show you how to actually read it, because it is a little different today. So now you need the T-chart, because this is when the population standard deviation isn't known, which is a repeat. All right, so then remember before break, and it was in a video of the 5 videos that I told you to watch from the JB Statistics guy, trying to give him credit where it's due. One of those 5 described yn minus 1, because I asked that myself, why? And not that it helped or not, but it's through normal curve analysis when you don't know the standard deviation of the total population, that parameter, then dividing by n minus 1 was a better result. I don't know. Watch that video again. So it's the same thing. That was because we're going to have to do some stuff here. So let's just move on and then tell you when that comes up. Okay. So since I don't know that, I don't want to keep repeating myself, it's not a z-test, it's a t-test. So that's why we need the t-chart. But now, I should have had the chart up here. So this is going to be cryptic as I write this down. This goes back all the way to August when I said, all right, just write these words down. A lot of times when you get the words, it doesn't quite make sense until we actually see it in action. So for a left-tailed test, again, a reiteration just to make sure we get the points down that we need. That's what, in terms of what is the alternative hypothesis, less than, left. It is a one-tail where you want to look on your chart. Okay, fine. Pull up that chart right now. I'm holding it up in class. Look up at the top of the chart, and those on the internet, you'll see this when I pull it up on page 2 of this. See how it says one tail, two tail at the top? Do you see it? So you look up at one tail, and then you go across for whatever the level of significance is, alpha. We'll do that. And then okay, again, this isn't going to make sense until I do it on the next page and show the graphs. T star is negative. Don't ask me yet. Don't ask me. Okay? Put that hand down. Do you guys get dizzy? Right-tailed, that means the alternative hypothesis was greater than some number. Use the one-tail row, but then T star is positive. Don't ask me why. I probably shouldn't have done this. I probably should have combined this page with the next page and explained this, but it's too late. And I won't change it for next year. I'll just say the same thing. I probably should have done this. And then if it's a two-tailed test, stop! Look up at the top of your chart. Do you see right below that it says two-tail? You're going to use the two-tail row. And then that's going to decide what column you're in. Again, hold off. And then why is T star plus and minus? Don't ask me that. Wait till the next example. Not the next thing I write. Wait till the next page. And then what you're going to do is actually graph a rejection region. And actually, where does the reject and fail to reject fall pertaining to the standard normal curve? Again, you probably don't know what that means. So I kind of put these together. For that first 1A, you shade to the left of T star. For the H sub A is greater than, T is a positive to the right of the mean of the standard normal curve, and you shade right of that. And then for the not equal to, that's a two-tailed. So you have T positive on the right, T negative on the left, and then you shade right and left respectively of that. You shade the tails part. Now I'm going to try this. This seems to be what's been messing me up, though. Did it go? Yeah, there we go. All right. So, boom. Sorry for all this junk that's up here. But this will be filled in with a picture. Okay, so let's actually, and look at what I have up here, and it works. I have a ZT chart up here. Yay. Okay, so then I can leave the PowerPoint and get to it and then go back to it. How great is that? All right, so here's a left tail test. So you read a question, and then you determine its left tail, just like you had to do yesterday. They tell you what level of significance you're checking. And then they tell you that there was 21 trials. There was 21 in this trial. 21 people, 21 candy bars, whatever. All right? So the degrees of freedom, remember, if there's 21 people that were in this study, if that's what the study was about, you check 20 on your chart. And then you check the following. Okay, so for alpha 0.05, so we're going to go to this now. See? Isn't that cool? Oh, actually, I have one up already. This is the better one. Okay, so now look up at the top. And I'm going to stay here and use my pointer if it can be seen online. Can you see that pointer at all? See that thing floating around? So it's a one tail, and it's at a level of significance of 0.05. So that's what you go at, and then that's the column you use, and go down to 20. This is the first time in forever that I've done this with you, right? Okay, and then you get 1.725. Fumble. We had a fumble in class. I had to cover that. Okay, so now I go back to this, and that's what we got for the t value. Okay, now is the time. Why in words did I write that it's negative? Because this is a left-tailed test, so this is what this really means. Standard normal curve, zero's in the middle. And then since it's a left-tailed test, we make this negative because it's 1.725 deviations to the left of 0. And then now, here's the new thing for you that you just have to accept and do. Wax on. Anyone? Okay, this is the border between reject to the left of this shaded or fail to reject. And now that's how we're going to make our analysis with a real-world question. Where does the data fall? Which region? The shaded or the unshaded, I mean. All right, now I'll keep saying it over and over again. It's a completely different thing. But really, there are 5 steps. Just 4 and 5 are a little different. What you have to do, or 3 and 4, I'm sorry. Okay, so then right tail test. We're going to go back to that chart. But now it's a level of significance of 0.01, and it's a right-tailed test. Of course, my degrees of freedom are 16, 17 minus 1. And then I'm going to go to the chart. All right, and we were doing a level of significance. It keeps opening up new ones. I just go back to my original. And by the way, this has the Z chart above it, and it's a little bit twisted. I used my phone to scan this in. Blah blah blah. Okay, it's a one-tail test, and it's at a level of significance of 0.01, right? And then what was the degrees of freedom? 16. So we're at 2.583. So that's the first time I've done this. 16, blah, blah, blah. Okay, now back to the thingamajobber. So that's what we have there. Now, we put that on the right because what that says, I should have done it again. Zero's in the middle. So we're 2.583 deviations to the right. And this is the line that separates the reject to the fail to reject situation, or regions in this case of probability. Although we're not going to find probability, we're going to do something else. And then, as you're writing this down, I'll do the last one, then I'll pause. Or actually, I'll just pause now. Hey! Oh, hey. Oh, you don't see it when sorry. Some people are common coring it. They were doing the last one by themselves. Is this what you got? Okay, degrees of freedom of 25. And then you went to your chart. I'll do this one last time. Blah, 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 blah. 0.05 again, right? Oh, it's a two-tailed. Let me explain this, though. Watch this. Now you go to the two-tail row, but look at above. 0.05. Look at above it. 0.025. Why do you think it says that for one tail? Because 0.05, each tail has what? 0.025. So this is just an easy way of you like picking the right column, I guess. It's a two-tail test at 0.05 because each tail holds 0.025 of the area. So I just wanted to share that with you. And then what was the degrees of freedom? 25? Okay, so you get it now. All right, I just wanted to show that two-tail thing. All right, and then going back. Oh, this is so much fun doing this online. So did you get that? Plus or minus 0.2060. And then this is the graph of it. Oh, by the way, fail to reject or reject who? I didn't write this down because I was lazy. This is the way they work this, I guess, is just to keep everything the same. Who do we reject or fail to reject? The null hypothesis, whether it's the claim or not, right? Okay, so get that in your head too. That honestly, I haven't taught this since 1991. How old were you in 1991? Actually, you were negative. Good. You're the first person to say that, right? And then since I took statistics, I don't know if I've ever done this. I don't know. It's weird. Okay, so now the next page. Just being honest. Okay, out of my comfort zone. Okay, so t-test for the population mean when oh, that's incorrect. Look at that. What does it say up there? Oh, that's the first time. Hold on. Let's do this online. Oh, this is great for... No. Ah! No, continue recording. Oh, geez. Now I may have screwed up the video. But there's a problem. Unknown, right? What I did is cut and paste it from yesterday's notes, but then I forgot that that was a possibility. Oh, first mistake. No one said a word all day long. Okay, so you only have the standard deviation of the sample, not the population. Caught that mistake. 6th hour. All the rest of the students are screwed up. All right, so how do you calculate the t-score? It's a different formula. What's different? It's one minor difference. The S instead of the, because you don't have sigma. So there you go. Now, as you're writing this down, I will talk out loud. That's how most people talk, by the way. Number 9 in your homework, they don't give you S, but what they do is give you a list of data. Uh-oh. How do you find from a list of data S? Calculator, and then what button do you have to ultimately have to hit after you type in the data? Variable statistics, and then it's the buttons depending on what your calculator to get there. So I did have one question to remind you how to do that. And then also that's how you have to get the mean, or you could just do the mean by hand, but that's not hard. Standard deviation is not easy by hand. We did do that earlier in the year, right? Yeah. It's a convoluted, crazy formula, just to get you a feel for it. Okay, so you know what? Don't write these down. We'll write them down on the next page. Just look at them. I think this will work better. Okay, here's what you're going to do for your 5 steps. It is a little bit different. Okay, don't write it down, because every step that we have in the word problem next needs to be restated. You are going to do the same thing in step 1. I don't have to restate that. Step 2, there are some differences. Identify the sample mean. On number 9 in your worksheet, you have to do that through one variable statistics. Identify S. On number 9, you have to go and do what I just said on the last one. All right, and then they tell you this level of significance, and then N, and then find the degrees of freedom, which is N minus 1. I should have put that in there. Next thing is, now just hold off on this. I had someone ask me this, and I can only kind of explain it in what I kind of understand out of this. But you calculate T star from the sheet. We just did that on the previous page. And then graph your regions. You know, graph where T star is, and then graph where the reject and fail to reject is. Then you use this formula to calculate T. What is not on this T? Star. I guess the best way to explain this is the standard deviation of the sample in a way. And then we want to find where it is in reference to where it should be. I have to go over here because my computer is running out of power. Okay? Can someone go get my mouse now? Because now I'm tethered here. Come on, somebody. I'll pause the video as we write this. Or no, I'll keep yammering as if they're listening. And then you make a decision. So this is all kind of graphical analysis. Where T is compared to where T star is and where the regions are to say do we reject or fail to reject. Okay, so I will pause it after we write this. Go ahead and write that problem down, and then we'll come back to you here shortly. Good. Oh, you know what? I did want to Common Core this out. Okay, write this out offline. This is what I'm going to do. We are going to Common Core right now. Oh, yeah. They fumbled, by the way. I forgot. All right, they can't keep focused. I guess that's my fault. Whatever. That's what everyone says. You know, got to raise these children, also teach them. I don't know. Okay. All right, here we go. So, step one. This is what everyone should have gotten, or else I have no comment. I don't want to be negative. That's not my way. Here we go. All right, so the claim is that the amount of hours that the professors have is equal to 11, so that makes it the null. Not equal, that makes it a two-tailed. And then we're checking at a level of significance of 5%. We really have to open this up again. But the next thing is, I'll do that later, identify these things. Now, like I said, number 9, you have to find these two by using your calculator, but it's given in the question. So you just have your ability to read and disseminate what is the information for each variable. That is actually a correct word. 3, calculate T from the sheet and graph the rejection region. All right, T star. Okay, so we have degrees of freedom of 7 at a level of significance of 5%. It's a two-tailed test. One last time, 5%, and I could go all the way up to there for two-tailed at degrees of freedom of 7. Is that what it was? 2.365 in this awful-looking sheet that I scanned today, but doing the best I can with the resources that I have. All right. So, plus or minus 2.365. This is how it graphs. Boing. And I put 0 here. That means I was being lazy. This is 2.365 deviations to the right and to the left of 0, and that contains the fail to reject region. The reject region is right and left of these two. Yeah? Later. Okay, so number 4, because I'm in the middle of something important. All right, now what you do is calculate T, and I guess you could just say this is for the actual sample that you have here, and everyone should have been able to do this because you have all the numbers to stick in the formula. And then what I did for first hour, I stopped and actually typed this for those that don't have the fraction button, because honestly, I saw someone today use this inappropriately. They put the little fraction on the top in the graphing calculator. It's hard to really figure out if you did that incorrectly or not. So it's 10.5 minus 11 over fraction. They put fraction over square root of 8. A completely different answer. You got to understand that. So I saw someone doing it, so I'm like, all right, well, even with these buttons, there still is a chance for a problem. So old school way always works. Numerator in parentheses divided by denominator in parentheses. No parentheses, no correct answer. I don't know what else to tell you. All right, so now here's the kicker. This is the first time you get to see, all right, how does this get all put together? Count this for this sample, I guess, boom, that you put this in the graph, right? And what this means, this negative 1.079 is for this little situation of eight trials or whatever, the result is that T is 1.079 deviations to the left of 0, which puts it where? In what region? It's the fail to reject region, and that's how you make your analysis. Okay? So now we are ready to go into number 5. Completely different than yesterday. All right? But it is what it is. So now what we do is get it? Okay. No, that's the other thing. Because the other thing's a different analysis because I think you have different data. So the way to work with it and how you make your comparisons has to be different. That would be the best way to say it. Okay, now we make a decision. What's already been decided. But here's the kicker for your sentences that I'm going to make you do. The sentences are in relation to the question. You don't just say, we fail to reject the null hypothesis, period. You actually go to the question and see what it means in reference to it. That's what I'm asking you to do from the last 3 days. So sure, we could say since this falls in the fail to reject region, sure, the null hypothesis has been failed to be rejected. But we really should say we can say there is sufficient evidence to indicate that the null hypothesis is okay, I guess. So there is sufficient evidence to indicate that the average number of classroom hours for a full-time professor at Tulane is 11 hours per week. Okay, and then that's what we write. I'm going to freeze that screen, end the movie, and probably start trying to compose it. Because I think I have to do this,